Let's take a closer look at the generation of the quark masses for the upper two generations. And what we want to look at is what we will call the combinatorial value of the rishons. For instance, if I put the mouse on this rishon and go over here, I can look and see that I have an ordered pair S and T, where S is 0 and T is -1 for that rishon. And if I use the formula twice the S value plus the T value, I will get what we would call N, or the combinatorial value. And so 2 times 0 plus -1 is -1. So the combinatorial value of this generic entity is then -1. Now, if we want to know the combinatorial value for, well, let's take a look at the anti-V. So after touching the anti-V graphic, I come over here and see that I have a plus or 0.5 or 1/2 for the S value, but I have a 0 for the T value. And so 2 times 1/2 is 1 plus 0 is 1. So now I have a combinatorial value of 1 for this anti-T part of the D quark. And if I add the combinatorial value for each one of these together, I will find that the total combinatorial value will be +1. Now, if I look over here at the boson plus, I touch the boson plus, the flavored V, and I will see I have a -1/2 and a for the S value and a 2 for the T value, and 2 times -1/2 plus 2 will give us 1 for the combinatorial value of the flavored V. And then again, I can look at this generic T and find I have 0 for the S value and 1 for the T value. 2 times 0 plus 1 is 1. And the sum of these components of the boson plus then will give a combinatorial value of 2. And we'll see that if we sum both the D quark and the boson plus together, we'll get the vector addition of 1 plus 2, which will give us a combinatorial value of 3 for the T quark. And what we want to look at and see what happens as the combinatorial value for the scalar bosons change. And so let's go down here to the B quark. And again, first we can look at, we have already done the D quark, so we won't do it again, but we can look at the flavored T, and we'll see that it has an S value now of -1 and a T value of 1, and 2 times -1 plus 1 will give us a -1 as a combinatorial value of this T, flavored T. And then if we look at the prime, we see that the prime will have the opposite. It will have 1 for the S value and -1. So 2 times 1 plus -1 will give us 1. So then if we take and do the vector addition of the combinatorial values on the boson 0, we'll find that we have 0. Now, if we go over to this boson 0, where we have a prime entity and a generic T, again, we first look here, and we will see that we have S equals 1 and T equals -1, and so we end up with a 1 as the combinatorial value of the prime Richat. Whereas on the T, we have 0 and 1, so 2 times 0 plus 1 is 1. So again, we look at the vector addition, and we will have a combinatorial value of 2. Now, let's look here. So we have a combinatorial value of 2 here, and a combinatorial value of 2 on this boson plus. Well, it happens that mass factors can only be carried by scalar bosons that have a combinatorial value of 2. We will see that all bosons will have an even combinatorial value. So again, this boson 0 here, which is composed of a prime and a generic, and this boson plus composed of a flavored and generic, both will have combinatorial values of 2, and they therefore will be able to carry mass factors. Whereas this boson 0, which has a combinatorial value of 0, will have no capacity to carry a mass factor. And that's why previously we saw that the generic D quark, its generic or intrinsic mass was only multiplied by the mass factor of this boson 0. And so therefore, the 500 times 10 times 2, which is 20, gave us 10,000. And in this case, we had 100 times 2, which was 200, with the electromagnetic factor turning the 500 to 2,500, and we got 500,000. So we can see that the generations will be determined by the combinatorial value as well as the mass factors that establishes the increases or decreases in mass. And so if we go here to the middle generation, then we'll see we have a boson plus, and this boson plus, since it has a flavored and prime together, we can look here and see that it has 0 for its combinatorial value, so will not carry any mass factor. And so that, but the electromagnetic factor changes this generic D quark into generic U quark, and therefore we go from 500 to 2,500, a mass of 2,500 for the charm RC quark. And here, having the generic D quark again, and again a boson 0 that will have a combinatorial value of 0, so therefore provide no mass factor, and then this S quark then will only have the mass contributed by the generic D, which will be 500 electron units. Now, we can see here that the combinatorial value for this highest generation, including the T quark and the B quark, in both cases will be the vector addition of 1 plus 2, which will be 3. So the combinatorial value of 3 is the value that establishes the highest or third generation of quarks, whereas the middle generation, the sum of the combinatorial values will be 1. And this 1 will establish the combinatorial value of 1 will establish the mass factors for this middle generation, as we've seen before, because the scalar bosons have 0 combinatorial value, then the masses are given in these cases by the generic quarks. So in this way, we see that we have this connection between the generations of the particles and the combinatorial values of the constituent orishons, determining whether or not the bosons, whether plus or boson zeros, will have mass factors or not, and therefore increase or decrease or have no effect upon the mass of the given particles.